how do we trust that that data from the installation part of the project is trustable?
How you do it is basically, if you don't know specifically what kind of machines they run, then you will model transport using market average transportation means. Then if you have contracts, for example, that I only allow people to supply me who use Euro 5, Euro 6 trucks, then you can actually choose that emission class of trucks, but you still don't know who is the actual transporter. But you take that in as an average still, but you know it's more precise average because it's a smaller subsegment of different specific type of equipment. And then finally, if you know the exact type of equipment and the exact emission class, you can use that. And the last event is if you actually know the specific fuel consumption and the type of fuel that was consumed, you can model it with fuel. So you have 4 options which all come from, more precise level to the less precise level.
Welcome to the Urbanista, where we discuss the water management challenges of Nordic cities. From safe drinking water distribution and stormwater collection to building sustainable urban living environments. Here is your host, Delphine Vesalo.
Hey, welcome back, Urbanistas. Thank you for pressing play. As more pressure comes to the construction industry to become more sustainable, the need for data and overall transparency in that data is increasing. It's super important to have this transparency. But from where this data comes, who verifies the data? That is accurate, that is true. What is the scientific basis that supports all this? That you have the claim that you can safely say that your product is complying with all the sustainability regulations? Well, today's guest at the Urbanista, is someone who is an expert and that can explain this and many more things. So, who are you and what do you do?
Yeah, hi. So, my name is Panu Pasanen. I'm the CEO and founder of One Click LCA. We do lifecycle assessment software for construction and manufacturing industries, and lifecycle assessment software uses a science-based methodology to quantify environmental impacts of either products or process using products and doing earth movements and other types of activities to achieve the project outcomes using science-based and standards-based methodologies, often with third-party verification of the results. And we do that worldwide. So One Click LCA is used in over 155 countries, and we are a Finnish company, about 20 years old, world leader in the LCA space in our domains.
So it's so nice to have you today, Panu. So you were mentioning already that all these elements are the ones that you put inside of your platform, your software. So can you just please, for the sake of understanding better, how exactly are you processing all this data, which what we mentioned at the beginning? So from where all this data comes that fits into your platform, into your software?
Yes, of course. So take 2 examples, like one, like a very simple, let's say, pipe network renovation project. So suppose you have a road that you need to dig open. So you will bring in, some machinery to cut open the asphalt, to peel it off. They will consume fuels. Then you will have some diggers digging off the soil, and you will pull out the existing pipes. Then you will undoubtedly put some layers of whatever materials to stabilize the soil underneath or achieve the right exact shape. Let's say you put in sand, and then you put in the pipes and insulation, and you connect everything and you recover it all. So you have 2 kinds of activities going, 3 kinds of activities in here. You have fuel using machines, and those machines in One Click LCA's case, you can measure them based on the direct fuel consumption if that's measured, or machine hours if you don't. Very common that you don't have the precise readings because it may be subcontracted work and you may not get all the information very precisely. Second, then you have the materials what you put in there. So if you put in there sand is not, let's say, a product that you go and buy in the market. So for sand and similar materials, you would use emission factors from One Click LCA's database. And then finally, for the actual products, for example, pipes, then you would use if available, manufacturer and product-specific environmental product declarations which contain the environmental impacts data. But if you don't have that data for a specific manufacturer or specific product you work with, then you would use generic data, which is the closest proxy of a similar type of a product, which doesn't represent the exact improvements and that the given manufacturer you work with has put into their products. So that's the example of projects, and there you end up with a figure that tells you this is how much comes from the machinery, this is how much comes from my products, and also what comes from end of life processing of the materials that you had in the project that you have to take away for disposal or treatment. Then
So
if
if
you
we
look at
take, yeah, go ahead, please.
so on the other hand, then if you have a product, let's take a simple PEX pipe, right? So for PEX pipe, there's going to be granules coming from basic chemical manufacturer, which come to the factory where the pipe is made, and heat is applied, and extrusion process follows. Some kind of gases and treatments may be applied as well, and the finished products are cut and packaged. And all of those activities, they also can be represented as environmental data, and that data comes again from One Click LCA's database. So we have a huge database, over 150,000 LCA datasets, from which the user can choose what actually is happening, and they can model the environmental impacts precisely. And because for the products, the output is typically environmental product declaration, and that requires third-party verification and publishing. The results would also be third-party verified and published before being used, and that increases the confidence basically you can have as a specifier or buyer of those products.
So if we break down this, because you clearly explained three pieces or three buckets of data. The first one is when the work is ongoing, all the machinery, the workers, the transportation, everything that involves the act of installing or building any given project. So that data, because you can say the trucks that we are using to bring the materials or the excavators, are those fossil fuel feed, or are those electric perhaps? So how do you get all that data, depending, because each project may be different? So how do we know exactly the the data from all those machines, all those trucks? Or is it also these transportation companies need to be certified somehow, or how do we get that? How do we trust that data from the installation part of the project is trustable?
Yeah, so how you do it is basically, if you don't know specifically what kind of machines they run, then you will model transport using market average transportation means, which is an average of different age of equipment, for example, and that kind of thing. Then if you have contracts, for example, that I only allow people to supply me who use Euro 5, Euro 6 trucks, then you can actually choose that that emission class of trucks, but you still don't know who is the actual transporter, and you don't know if they have a bit heavier foot on the pedal than the other guy. But you take that in as an average still, but it's more precise average because it's a smaller sub-segment of different specific type of equipment. And then finally, if you know the exact type of equipment and the exact emission class, you can use that. And the last event is if you actually know the specific fuel consumption and the type of fuel that was consumed, you can model it with fuel. So you have 4 options which all come from more precise level to the less precise level, and what level you have to use depends on how material is transported for your product. So you need to have higher quality of data for the higher impact part of your activity.
All right. So the second bucket that you were mentioning is the material that is already on the site. More often than not, when excavators come and dig out whatever is the material, sand, gravel, etc. Sometimes that gravel may be already contaminated because of whatever historical reason, so they need to be substituted by new by new sand or new filling material. That new filling material, okay, we know from where it comes. We kind of want to, we can measure it or we can quantify it. But the one that is already in the case that we will reuse it, I mean, not putting new material, reuse that same material, we don't know what is down there on the ground. So how do we can measure that, or is it again an estimate, an average?
You mean where do you go? Where do you put that? As in whether it's contaminated or whether it's
Exactly, because yeah, the example is that many times we dig out a lot of material, and if there's the need because of pollution or whatever reason
yeah,
to substitute with new material, that new material we know from where, fine.
yeah,
But
yes,
in the case that we reuse the same material,
yes,
it
yes,
was
yes,
already down there for 40 years. So how do we know what is inside there? And we are going to open, change whatever infrastructure or piping, whatever need, and
yeah.
fill it with the same material. So then, how does that count?
Yeah, so in terms of assessment, you need to establish if you actually have to replace it. So if it's going to be contaminated and it has to be processed, then you would be able to model that simply as contamination process for that amount of, gravel or soil or whatever sand you may have. And then you need to calculate the substitution with primary or secondary material, but not the same anyway. So from LCA point of view, if the materials were there already, they are counted as zero. So you're not incurring impacts for reusing the same material, except for digging them up and putting them back in for the machinery and transporting them if you have to transport them further. But then if you do need to process the soil, you are responsible for processing the soil, and those impacts will be burdened on your project. And it may not be knowable before you open the road in this case. So, but if you didn't know, then you still have to do it. So it's an actual environmental burden, and that would be then measured using soil sampling. So it's not knowable ahead.
Okay, soil sampling. Okay, so we have the machinery or the operational part to do the project. We have the actual soil or whatever was already. And then the third piece is, well, the new products that we are going to put into to build whatever project or whatever installation are we intended to put there. So you were elaborating on a few things. I guess the one of the things that most people put the emphasis is the material in which from which that pipe or whatever chamber or whatever element is made of,
Yes.
which is in many cases, if there is concrete, if there is aluminum or steel, or if it is plastic. So those each one of those have, of course, different or very different carbon footprints depending the processes that they were used to build. In a general level, which one would you say may have less or more footprint of all this concrete, plastic, and steel?
Yeah. Good try. Yeah. No, I'm not commenting on that. So
Okay.
how it works is that in life cycle assessment, what you want to know is what is the total impact over the life cycle. So you have to look at what you're gonna do, in the project. So giving some very practical and simple examples. So if you have a pipe, let's say a sewage pipe, in an area which can be having storm floods, and if it's a heavy concrete pipe, it's going to be massive, and it can be maybe on its own. But then if you have a lighter material pipe, e.g. plastic, then it may have to be anchored with concrete anchors. So you actually have to look at the total impact it has at the as-built stage and also over the life cycle. So if you have a material which allows it to live longer or maybe be more adaptable or more reusable, you can have those impacts considered too. And there's no like a answer that you can standardize everywhere, but for a same context, you can standardize the answer, of course. So if you always do the same thing in a similar, let's say, geology, similar usage and others, yeah, there are going to be optimums that you can reach, but it's not completely generalizable. And lastly, obviously, similar to any other industry in the world, steel, plastic, and concrete manufacturers, they all work to improve their products. So the product development improvement rate also matters, and pipe elements, they can be left for curing for longer, for example, or plastic manufacturers can use more recycled plastic, and steel, of course, very high recycling rates. So there's kind of, let's say, ongoing race for everybody to improve, as it should. I mean, we cannot have any materials left that are having net carbon emissions in a short time. So everybody has to do better over time.
You just mentioned one key word, which is recyclable or recycling, because we have been hearing a lot. Okay, we can measure at this point from so-called from cradle to gate. So from the point of when the materials are getting out of the manufacturing facility and then installed in whatever is it. They will be there for 10, 20, 100 years, whatever is it. But then afterwards, what happens? Or the scope of the analysis that you are doing is until the project and the products are installed. But then somebody in 50 years, in 100 years, and actually I believe that is a problem, generalized problem in our industry, in about 50 or 100 years, when the end of life for that product it comes, what will happen? I mean, then somebody needs to come and pull them out, and then how do we go about that?
Yeah. So in life cycle assessment, you look at the whole life cycle. It's possible to make a deviation from that. So, for example, to make a simplified calculation and only consider as-built phase, but it's not very sensible. But you can, right? But in general terms, you should look at the whole life cycle, including end of life, and you should add up the impacts. And how you look at end of life is that because it's future looking, you cannot come up with your own vision of the future, because that would lead to greenwashing, because everybody would come up with claim that by 2050 everything will be beautiful, and in my product's case it's going to be even more beautiful than that. So how it works is that you need to use actually provable things, and typically that means statistics. So you assume that what's being done today is what's going to be done then. It's not like showing any progress, but that's also reversing the burden, because you have to make the progress happen before you can achieve that. So with producer responsibility associations, for example, which are able to directly influence, the amount of recycling and that kind of items, you can improve the recycling rates for your LCA's end of life as well. But you're not able to just get a free pass by claiming something. And in case of specifically the pipes, the economic case is that they are not often dug up. Metal pipes maybe, just for the economic value they have, but so there's that. And in many cases, infrastructure pipes may not be recovered unless the same, obviously, route is going to be reused for other types of things, in which case they would. So it depends on a bit on the recurrence of the need for construction on the area, which you can predict or not.
Well, yeah, exactly, and that's what I meant. That this is a problem or a situation that needs to be clarified as the whole construction industry and all the players, and of course, not neither you and me will be here in 100 years to figure out what's going to or how it's going to be, but at least to have set the rules.
To make maybe just to put like very simple rules out there. So I think in an urban setting where you are building in a city area with some density, it's very likely that the area is going to be dug up again, because there's going to be another type of infrastructure that's going to be needed, even if it's not exactly the same, maybe cable infrastructure or whatever. And so we can assume that kind of recurrence, even if, let's say, certain city doesn't continue district heat for a certain area, but cable networks would probably still be needed, and water pipes. And so you can very easily argue that in an urban scale. But then if you move to infrastructure and you do, for example, some rural area, let's say my summer cottage, I pulled there, water 3 years ago. Not too sure that anybody's going to ever dig that part of the forest up and again. So, I mean, It's not going to have any end of life. It's going to stay there. So just to frame it in very pragmatic way.
Exactly. So talk about a bit more about this criteria for the environmental product declarations, which is the main outcome actually that you collaborate with, that your platform issues. So which are how do you build, or what is the process to collect and produce the any given environmental product declaration?
Yeah, so environmental product declarations are called EPDs after the initials, obviously. And EPDs are third-party verified and practically always published documents about a specific product or range of products and what environmental impacts they have. And these documents, they are made in accordance with European or international standards. And these standards are pretty close to each other, so EN and ISO standards are not that far. And these standards set rules on how you need to calculate an EPD, pretty normative rules, so you have great level of detail. And once a manufacturer has calculated an EPD for their product, let's say, Uponor has a new pipe which is made with some kind of environmental innovation, new material or such. The calculation is completed, but the big point of the environmental product declarations is that they get third-party verification. So, in this case, Uponor would have to submit it to either third-party verifier or directly to an EPD program operator who engages a third-party verifier to do the verification, depending on which is the workflow. And the document would not get published before it's been signed off by a third-party verifier. And if the verifier is not happy, it's not going to go public. So the design principle of these is that environmental information is relatively complicated to understand, and people would have difficulty judging its quality without it having been independently verified. So this third-party verification is a mandatory step for environmental product declarations, and it allows you to trust the data actually.
Because what we have seen is overall with the new products, because if you have, let's say, in the scenario that you have a product that you are improving, a product that already existed for a few years, so you kind of have one benchmark. So the new product, which is made with or based on any type of renewable material, okay, you can, to some sort, you have compare. But if you have a product, brand new product that didn't exist before, there's no previous data, there's no benchmark or point to refer to that. So then how the EPD can claim that is more or less, so still more or less, the level of carbon footprint. So there should be some historical data, at least a minimum historical data.
Well, in this case, if it's a completely new product, you don't claim it's better than your previous product because you didn't have a previous product. So you're claiming actually that it is better than an alternative solution. So in this case, you would have to figure out what is the alternative. Let's call it counterfactual, as it would be referred to, let's say in more official terms. So what would that be? How would this problem have been solved if this new product wasn't used and available on the market? And you need to find out those things, right? And it can take a fair amount of time. Usually it comes from your customers because it's not a problem that you have, it's a problem that your customers have that you're solving with the product. So finding out that data from your customer, and it can be quite contextualized. So let's say you have something to do with pumping, for example, and pumping is of course fundamentally always a question of flow and gravity and pressure and whatnot. So under what scenarios, for example, does it have this performance improvement? And that kind of matters would be needed to achieve a reasonable counterfactual. And if you make comparative statements, you should be very clear about what your counterfactual is, because the gain may be different for scenarios A, B, and C.
And all this is of course, in the spirit of having this data transparency, and that is what everybody wants to avoid, of course, the famous greenwashing. And that's why, well, we have this third party verified and EPDs. And that's one of the points that, yeah, you have it and it's clear. So it is not you or the manufacturer or the person installing who claims that I am sustainable, whatever, X carbon footprint less, but it's some document, some clear document that says so, and that is one of the key benefits of the EPDs.
Yeah, that's right. So, and there's multiple layers of scrutiny and control in environmental product declaration. So, let's take manufacturer who in good faith makes a mistake. They didn't know how some rule was applied. Okay, in EPD process, the verifier would very likely catch that mistake, right? And they would tell you, yeah, I cannot sign this off because you have this mistake. You need to go and fix it and send it back again. And if the verifier didn't catch it, and then the data goes to the market because the EPD program operator would not re-scrutinize every EPD to the extent because they need to also rely on their verifiers. But it's going to be a public document. And that's an important thing because all the competitors would be like, what? Why are your numbers like this? I don't understand it. We do broadly same thing or not? And then they would probably complain about it to the EPD program operator. And if the EPD program operator heard this a few times, they would probably ask for these documents from the well, I mean, they would already have the documents, so they do have the background documents and the notes, and they can mandate a re-verification of the document in question or unpublish it if it's completely sketchy. So, and these multiple layers of scrutiny. So first, manufacturer being willing to put their own name on it. Second, the third-party verifier willing to put their own name on it. And third, EPD program operator willing to put their own name on it. All of these, they add to the level of confidence you can have on these documents. And, not every EPD ever published has been correct, but then they can be withdrawn. And in our case, for example, in One Click LCA, when we work with environmental data for construction sector who use product data, we also do blacklist some data because we see it's published EPD, but we think there's some problem with it, and we just blacklist them. We don't care because we want the users to be able to use data with confidence, and if we have question marks on data which we can't reasonably resolve, then we just don't let that go into our database.
Exactly. So you now just explained, of course, all the process that takes to create the end document. So it's really strict, and it's still, if as you say, okay, in good faith, okay, well, assuming that it was an unwilling mistake, some inaccuracy goes. So still, there's a way to, of course, to go back and to reassure that the system is working correct and the calculations in the software are correct and the final document is trustable. And it's still, if there's some thing, there's still a way to send it back. All these documents, and this is something that we have heard from mostly from the project managers, the people who are in the planning phase, that they may have different types of documents and still different types of EPDs for if they are choosing one versus the other product. So, and they have two EPDs, like, okay, how do I go about this? So they don't look the same. The criteria don't look like the same things that I can really compare one versus the another. Or is it still, anyway, is it valid? A one-to-one comparison of EPDs, or how do you see it?
Yes and no. So EPD standards have changed in the last couple of years. So since 2020, we have a second generation of the European standards for EPDs. It's called EN 15804, and it has the Amendment 2 version ongoing since a couple of years. And at that point, the calculation and reporting metrics changed. So the EPDs done before that and after that are not comparable with each other directly. There's a way to make them comparable. So if you would use them through One Click LCA software, you can see them in a comparable manner. But if you're just looking at the documents, they are not. So then you actually have to look at the standard version. So if you have the same standard version, there's something really strange if you cannot compare them, because they have to report the same numbers with the same standard. I mean, they have to report on the same metrics with the same standard version. So
Okay,
regularly you shouldn't
if I
have
can
any
recap,
legitimate. Yeah.
okay, because if I can recap, so for the sake of clarity, if okay, we are evolving all the time. The criteria is evolving, as you said, they are changing. An EPD that was issued in, let's say, 2020, under the criteria of 2020, it was correct and accurate and valid, but then the criteria kept changing over the next 2-3 years. So we should say right now that EPD may or may not be valid anymore.
EPDs are valid for 5 years from publishing. So
Five
uh,
years.
we still have valid EPDs which represent the older generation of standards, but no new EPDs are published under those standards anymore since sometimes. So all the new EPDs are published under the new generation of standards.
Okay, so that is the way to at some point to let the old ones phase away as they get old. Of course, they are no longer. So that is the first key for whoever is planning, is trying to compare and do their own calculations for the project. What would you say the person calculating or evaluating a project, which lines or which items in an EPD should be the most important that they should look at?
So in environmental product declarations, the the names of the environmental impacts are derived from standards, and in the European standards, the global warming potential fossil is the one to look at. So we have biogenic impacts and we have fossil-based impacts. And for biogenic impacts, they are often considered to be reverting to the nature in a way. So burning wood is considered zero carbon, even though of course it does emit carbon molecules. It's kind of a life. But so we are looking at global warming potential fossil, GWP fossil, and then for sake of comparability and simplicity, I would, for product specification for any simple products definitely, and which are directly comparable, so one-on-one comparable, like let's say plastic pipes to plastic pipes, I would always recommend to consider only the sum of the impacts at cradle to gate level, so including raw material extraction, raw material transport to manufacturing, and raw material manufacturing and packaging. So that would then be what's called A1 to A3 life cycle phases. So GWP fossil for A1 to A3 is the number to look at. That represents the fossil fuel derived emissions arising out of the manufacture of the product until it's at the factory gate. And why you don't look at all the other parameters is because if EPD is published, it's not published for you. So for example, for the transport distance, it's not going to be that transport distance for you. It's generally the transport distance in some scenario. And if you're looking at the end of life, if you, for example, have manufacturers from 2 different countries which are eligible for your project, their statistics for end of life treatment may be different. And it doesn't make any difference for you because in your specific context, just one scenario will be true. So keeping it quite simple is important. Then if you get into not like for like comparisons, but where you consider the example of pipes which are heavier and don't need anchoring and pipes which need anchoring, then you cannot compare anymore at product level. Then you need to compare the whole system. The only way to look at it in such scenario is a system level, because anything else is leading to misrepresentation, basically.
You mentioned also a moment ago that an EPD can be for a specific product, a single individual product, or for a range of products that, well, I guess they look like the same or they follow the same process. So how valid are those two? I mean, if I have on one hand a product specific EPD and on the other is just the family of product range of products. So those are not really comparable. I mean, ideally should be product specific EPD always?
Yes and no. So it depends on the product. So let's say we take an example of let's take a pipe which has insulation layer and then another pipe around it again. So then you have a product which is non-linear because the insulation layer presumably stay similar thickness, whereas the pipe diameter would grow, let's say, or something. So you may not have linear scaling, for example. But then if you consider monomaterial product like plastic pipe, which is untreated and everything, you may sell it as rolls, which are like, I don't know what's the length, but very long. You may sell it in different sizes and that kind of thing. And they are actually all very much monomaterial. So you can very simply represent much of that kind of product by mass, because all the impacts are directly correlated to on a linear basis to mass. So it depends on what is representative of the product physically. So if you look at, for example, concrete elements which are made with prefabrication. So if you have elements which include reinforcement, the reinforcement typically scales non-linearly with the product. So there you would actually need to have more specific data always. But if you have a product which is monomaterial and in many ways simple, mass can be a good proxy for it.
All right. So there are many elements that we have been discussing to unpack, and I will try to do this summary on this episode show notes. If we zoom back a bit, we have all these big goals, mainly by the European Union, which is to make carbon neutral cities by, was it 2035, I believe, or 2050. So how far do you think we are as the whole industry to really get there? Okay, different countries have different levels of maturity, of course, but in the Nordics specifically, what would you say? How far we are? How close we are?
At the country level, we are quite far. So we have leaders in the industry who do broadly, let's say, enough. But we also have many players in the industry who don't have the same pressure from their competitive positioning point of view or from their clients, and who don't do nearly enough. So literally the only way to get everybody to do enough is to leaders to keep leading and the regulation to force everybody to catch up. And now legislation has taken effect in Norway. It has taken effect in Finland. It has taken sorry, not in Finland, but in Sweden and Denmark. In Finland, that's in these governments' plans. And but first we need to get the legislation in place, and then every 2 or 3 years we have to make them tighter. But it's we need to get, if we want to get carbon neutral as a society, it means that nobody can have carbon emissions. It's not the question of the leaders leading. It's like everyone, and we're not nearly there in terms of the entire industry moving fast enough. So, and that will need carrot and stick.
Yes, that's what we have been hearing. So that's, as long as the legislation is not in place, like, well, forcing, if you want, forcing the different stakeholders to move, it will be a bit difficult to do. Panu, anything else that you would like to add to conclude this conversation? The importance of considering this documentation, the importance of being accurate in the data. Anything else that you would like to add?
Well, I mean, you build in infrastructure mostly 100-year assets, or often, yeah. So you can only get them right once at the design stage. So this whole thing needs to be considered not in procurement stage, but in design stage, because where do you dig? What line are you going to choose? What materials are you going to use? And all that determines the impact you're going to have. And there's no going back after that. So once you sign off the contract to somebody to build it, it is going to be what it's going to be, more or less. And I would really encourage to think about this 100-year time span as your one shot at contributing for the actually achieving these carbon neutral cities goals. And it doesn't also have any cost extra, because if you think about it carefully, these are inputs that don't come for free. Like diggers don't come for free, pipes don't come for free. Mm-hmm. Thinking about how to get to an optimal and resource efficient solution is typically best economics you can have. and incorporating these into your design targets should be the way to go, because it can help you unlock just financial savings as well as very substantial carbon and other environmental impact savings.
Well, there you go. Is not only that we are working together to have a better environment. There may be some financial savings, some financial benefits, which of course nobody will refuse to have those. All right, so Panu, thank you so much for your time today. This has been very insightful, and hopefully our audience will have found this very insightful. And thank you so much, and see you next time, Urbanistas.
Thanks.
Thank you for listening to the Urbanista podcast, a production of Uponor Infra, the leader in sustainable infrastructure solutions. If you found it interesting, why don't you share it with your colleagues? We all together can move our industry forward.